Top 25 SQL interview questions and answers. In the competitive landscape of technology jobs, SQL skills are often a prerequisite for many roles. This video presents the top 25 SQL interview questions and answers to help candidates prepare effectively for their interviews. Whether you are a beginner or have some experience, understanding these questions will enhance your confidence. The insights shared will equip you with the knowledge to impress potential employers and stand out in your interviews. 1. What is SQL and what are its main uses? SQL, which stands for Structured Query Language, is a standardized programming language utilized for managing and manipulating relational databases. Its primary functions include querying data, updating records, inserting new information, and deleting unwanted entries. SQL is used for various purposes, including data retrieval, data definition, and database administration. Common applications involve generating reports, analyzing data trends, and ensuring data integrity. Due to its versatility, SQL is widely adopted in industries for data management, enabling organizations to effectively handle large volumes of information. 2. Explain the different types of SQL commands: DDL, DML, DCL, TCL. SQL commands are categorized into four main types. 1. DDL, Data Definition Language. These commands define the structure of the database. Examples include create, alter, and drop. They are used to create, modify, and delete database objects like tables and schemas. 2. DML, Data Manipulation Language. This set of commands is used for managing data within those structures. Examples include insert, update, and delete. They allow users to add, modify, or remove records in a table. 3. DCL, Data Control Language. DCL commands are used to control access to data within the database. Examples include grant and revoke, which manage user permissions and roles. 4. TCL, Transaction Control Language. This set deals with transactions in the database. Commands like commit, rollback, and savepoint manage transaction states, ensuring data integrity. Each type plays a vital role in database management, enabling users to perform various operations effectively. 3. What is a primary key? How is it different from a unique key? A primary key is a field, or combination of fields, in a database table that uniquely identifies each record within that table. It ensures that no two rows can have the same primary key value, thus maintaining data integrity. A primary key cannot contain NULL values and is used to establish relationships between tables. On the other hand, a unique key also ensures that all values in a column are different from each other, but it allows NULL values. This means that while a unique key can enforce uniqueness, it does not have to be used as the main identifier for the records in the table. In summary, every primary key is a unique key, but not every unique key is a primary key. 4. What is a foreign key and why is it important? A foreign key is a column or a set of columns in a relational database table that establishes a link between data in two tables. It is a reference to the primary key in another table, ensuring referential integrity. This means that the foreign key value must match an existing primary key value or be null. Foreign keys are crucial for maintaining consistent data across related tables, preventing orphan records, and enabling efficient joins in queries. They also help define relationships between tables, which is essential for structured query operations and database normalization. 5. What are indexes in SQL and how do they improve performance? Indexes are special database objects that improve query performance by allowing the database management system to find rows more quickly. They function like a book's index, enabling fast access to data without scanning the entire table. When an index is created on a column, the database builds a data structure that stores the values in that column along with pointers to the actual rows. This reduces the amount of data the database needs to search through for queries, leading to faster response times, especially for large tables. However, it's important to note that while indexes enhance read performance, they can slow down write operations due to the overhead of maintaining the indexes. 6. Write a SQL query to find the second highest salary from an employees table. Select max salary as second highest salary from employees. Where salary less than, select max salary from employees. This query retrieves the second highest salary by first finding the highest salary in the employees table. It then selects the maximum salary that is less than this highest salary, effectively giving the second highest salary. This approach avoids using complex ranking functions or subqueries beyond the necessary scope, making it efficient for most relational database systems. Ensure your employees table has the relevant data to execute this query successfully. 7. Write a SQL query to fetch duplicate values from a column in a table. Select column underscore name, count asterisk as duplicate underscore count. From table underscore name, group by column underscore name, having count asterisk greater than 1. This SQL query retrieves duplicate values from a specified column in a table. It selects the column of interest and counts the occurrences of each value using group by. The having clause filters the results to include only those values that appear more than once, indicating duplicates. Ensure you replace column_name and table_name with the actual names relevant to your database schema. This approach is useful for data cleaning and integrity checks. 8. How do you retrieve the top-n records from a table? To retrieve the top-n records from a table, you can use the limit clause in MySQL or PostgreSQL, for example, to get the top 5 records from an employees table. The query would be: select asterisk from employees, order by salary DESC, limit 5. In SQL Server, you can achieve this using the top keyword. Select top 5 asterisk from employees, order by salary DESC. In Oracle, you can use the RONUM or the fetch first clause. Select asterisk from employees, order by salary DESC. Fetch first 5 rows only. These queries effectively return the highest salaries based on the specified order. 9. Write a SQL query to find employees whose salary is above the average salary. Select from employees, where salary greater than, select AVG, salary, from employees. This SQL query retrieves all records from the employees table where the salary of each employee exceeds the average salary of all employees. The subquery, select AVG, salary, from employees, calculates the average salary, and the main query filters out employees whose salary is higher than this calculated average. This approach allows businesses to identify high-performing employees who earn above average within the organization, aiding in talent recognition and retention strategies. 10. Write a SQL query to count the number of orders placed by each customer in an orders table. Select customer ID, count order ID as number of orders. From orders, group by customer ID. This query counts the number of orders for each customer in the orders table. It groups the results by the customer ID field, allowing the count function to tally the corresponding order ID entries for each unique customer. The result will yield a list showing each customer alongside the total orders they have placed, providing valuable insight into customer activity and ordering patterns. This type of analysis can be useful for sales strategies and customer relationship management. 11. How can NULL values be handled in SQL? Handling NULL values in SQL requires understanding that a NULL represents the absence of a value. You can use the as null or as not null operators in queries to filter records. To replace NULLs with a specific value, use the coalesce, or if null, functions. For instance, coalesce column_name, default_value, returns default_value. If column_name is NULL additionally, when performing calculations, ensure to account for NULLs as they can affect results. Functions such as count ignore NULL values, while others may return null if any operand is NULL proper. Handling ensures data integrity and accurate query results. 12. Write a SQL query to update the salary of employees by 10%. Update employees. Set salary equals salary asterisk 1.10. This query increases the salary of all employees by 10%. It works by multiplying the current salary by 1.10, effectively adding 10% to the existing amount. Make sure to execute this query with caution, as it will affect all records in the employees table. To target specific employees, a where clause can be added to filter the records that should receive the salary increase. 13. What are group by and having clauses? Give an example. The group by clause is used in SQL to arrange identical data into groups. It is often used with aggregate functions like count, sum, AVG, etc., to perform operations on each group of data. The having clause is used to filter records that work on summarized group by results. Unlike the where clause, having is used after the aggregation has occurred. Example: select department, count asterisk, as employee_count. From employees, group by department, having count asterisk greater than 5. In this example, the query retrieves departments with more than 5 employees, grouping the results by department. 14. Explain different types of JOINs in SQL. Give examples. In SQL, JOINs combine rows from 2 or more tables based on a related column. The primary types include inner JOIN, returns records that have matching values in both tables. Example: select employees, name, departments, name. From employees, inner join departments on employees, department ID equals departments, ID. Left join returns all records from the left table and matched records from the right table. Unmatched records are NULL. Example: select employees, name, departments, name. From employees, left JOIN departments on employees, department ID equals departments, ID. Right join returns all records from the right table and matched records from the left table. Unmatched records are NULL. Example: select employees, name, departments, name. From employees, right JOIN departments on employees, department ID equals departments, ID. Full outer JOIN returns records when there is a match in either left or right table records. Example, select employees, name, departments, name. From employees, full outer join departments on employees, department ID equals departments, ID. 15. What is a subquery? Provide an example. A subquery is a query nested within another SQL query. It can be used in select, insert, update, or delete statements to provide results for the outer query. Subqueries can return a single value, a list of values, or a complete table. They are useful for breaking down complex queries into simpler parts, allowing for better readability and maintainability. Example, select employee ID, employee name. From employees, where salary greater than, select AVG, salary, from employees. In this example, the subquery calculates the average salary, and the outer query retrieves employees whose salary exceeds that average. 16. What are window functions? Write a query using a window function. Window functions are a category of functions in SQL that perform calculations across a set of table rows that are related to the current row. Unlike aggregate functions, which group rows together, window functions allow for the calculation of values while still retaining the individual row data. Common window functions include row_number, rank, and sum. Here is an example of a SQL query using a window function. Select employee_id, salary, rank, over, order by salary DESC, as salary_rank. From employees, this query ranks employees based on their salary in descending order, providing a unique rank for each employee. 17. What is a common table expression, CTE? How is it used? A common table expression, CTE, is a temporary result set that can be referenced within a select, insert, update, or delete statement. CTS improve readability and organization of complex queries. They are defined using the with clause followed by a query that generates the result set. CTS can also be recursive, allowing for hierarchical data processing. They can simplify complex joins and subqueries, making SQL code easier to maintain and understand. Using CTS helps break down complicated logic into simpler, reusable components within a single query context. 18. Explain the difference between union and union all with examples. Union and union all are SQL operators used to combine the result sets of two or more select queries. The key difference lies in how they handle duplicate records. Union removes duplicate entries from the combined result set. For instance, if you have two select statements, select city from customers, union, select city from suppliers, this combines cities from both tables, excluding duplicates. Union all, on the other hand, retains all records, including duplicates. Using the same example, select city from customers, union all, select city from suppliers. This will show all cities, including duplicates, giving a complete picture of entries across both tables. 19. What is normalization? Describe different normal forms. Normalization is a database design process that organizes data to minimize redundancy and dependency. It involves dividing large tables into smaller, interrelated tables and defining relationships among them. The main goal is to ensure data integrity and efficient data management. The different normal forms include: first normal form, 1NF, ensures that all columns contain atomic values and each entry is unique. Second normal form, 2NF, requires that all non-key attributes are fully functionally dependent on the primary key. Third normal form, 3NF, eliminates transitive dependency, ensuring that non-key attributes depend only on the primary key. Boyce Codd normal form, BCNF, a stronger version of 3NF, where every determinant must be a candidate key. These forms help structure data efficiently, reduce redundancy, and maintain consistency. 20. Write a query to pivot a table to show totals by month for each product. Select product name, January, February, March, April, May, June, July, August, September, October, November, December. From select product name, month, order date, as order month. Sum, quantity, as total quantity. From orders, group by product name, month, order date, as source table. Pivot, sum, total quantity, for order month in, 1, as January, 2, as February, 3, as March, 4, as April, 5, as May, 6, as June, 7, as July, 8, as August, 9, as September, 10, as October, 11, as November, 12, as December, as pivot table. This query transforms sales data from an orders table by summarizing total quantities sold per product for each month. The inner query aggregates data by product and month, while the pivot function rearranges the data to create a more readable format, displaying each month as a column. This allows for quick analysis of product performance over the year. 21. What are ACID properties in SQL transactions? ACID properties ensure that database transactions are processed reliably. ACID stands for atomicity, consistency, isolation, and durability. Atomicity guarantees that all operations within a transaction are completed successfully. If any operation fails, the entire transaction is aborted. Consistency ensures that a transaction brings the database from one valid state to another, maintaining all predefined rules, such as integrity constraints. Isolation ensures that concurrent transactions do not interfere with each other, providing a level of separation. Durability guarantees that once a transaction is committed, its changes are permanent, even in the event of a system failure. These properties are essential for maintaining data integrity and reliability in databases. 22. What is the difference between clustered and non-clustered indexes? A clustered index determines the physical order of data in a table. Each table can have only one clustered index since the data rows themselves can only be sorted in one way. In contrast, a non-clustered index creates a separate structure from the data rows, containing pointers to the actual data. A table can have multiple non-clustered indexes, which can improve query performance by allowing faster lookups. While clustered indexes are ideal for range queries, non-clustered indexes are better suited for queries that involve searching for specific values. 23. What is a trigger? Give an example use case. A trigger is a special type of stored procedure that automatically executes in response to certain events on a table, such as insertions, updates, or deletions. Triggers are useful for enforcing business rules, maintaining data integrity, and automating tasks. Example use case. Consider a sales database where you want to track changes in the inventory when a new order is placed. You could create an after insert trigger on the orders table that decreases the quantity of the ordered items in the inventory table. This ensures that inventory remains accurate without manual intervention. 24. What is a stored procedure? Write a basic example for returning order history by customer. A stored procedure is a precompiled collection of SQL statements that can be executed as a single unit. It is stored in the database and can accept input parameters, return results, and encapsulate complex business logic. Stored procedures enhance performance by reducing the amount of data sent over the network and can help maintain security by controlling access to the underlying data. Here's a simple example of a stored procedure that retrieves order history for a specified customer. Create procedure get order history by customer. At customer ID int. As begin, select order ID, order date, total amount. From orders, where customer ID equals at customer ID. Order by order date DESC. End. This procedure takes a customer ID as input and returns their order details. 25. What are common data types in SQL and why is data type selection important? Common data types in SQL include integer, varchar, date, float, boolean, and text. Selecting the right data type is crucial because it affects storage efficiency, performance, and data integrity. For example, using an integer data type for age ensures accurate calculations and saves space compared to using a varchar. Additionally, selecting appropriate data types helps prevent errors during data insertion and retrieval. Proper data type selection also enhances query performance, as the database engine can optimize data storage and access patterns more effectively. In this video, we've explored the top 25 SQL interview questions and answers that can help you prepare for your next job interview. Understanding these concepts is essential for showcasing your SQL skills and enhancing your chances of landing the position you desire. Whether you're a beginner or looking to refresh your knowledge, mastering these questions will give you a competitive edge. If you found this content helpful, please like the video and subscribe for more valuable insights and tips. Your support helps us create more informative content for you.